let us return to logic based. In logic based, we can use a stumps architecture which I mentioned, right. So, we can have a PRPG, we can have a phase shifter, then we can have a sequential circuit here with scan chains, and then there could be a sort of a reverse phase shifter, then there could be an MISR. So, this is a stumps architecture. What is the advantage? No tester is required now. Okay. We can allow the circuit to test itself and output the signature. And if the signature is different from that of a good circuit, we can conclude that it is a faulty circuit. It could also be such that it may be possible for you to suppose we know that the golden signature happens to be 1011. This is the golden signature. So, I can build a small gate like this, and this can be our go or no go. Meaning, if the signature is 1011, then this guy will say I am okay. If it is anything other than 1011, it will say no, don't go. So, it will produce a error. Okay. So, this is also one way to make things happen. Okay. Sometimes you can also adjust the seed and the number of clock pulses, etc., to make sure that the signature is 0000. Adjust it to be all 0 pattern. If you can do that, that's also makes a lot of sense, right? If you get anything other than zeros, then sorry, something wrong in the circuit. While we can do all this, right? It as I explained to you in a previous class, the advantage of logic based is it eliminates the need for a tester. It increases the cost a little bit because now we have to include the PRPG, MISR, all these phase shifters, etc. Right? Earlier, these were coming from the tester, and these are also going to the tester. But now it's all inside. Okay. So, some little extra area, etc., will be there. But more than that, what is unfortunately going to happen is we may not get all the adequate fault coverage. We may not get 100% fault coverage. Using only random vectors. Okay. So, that is a problem. Some faults you will not be able to test with only random. So, you will need, let us say we get about 80% coverage with random patterns. Then the remaining 20% you will have to rely on the tester, automatic test equipment. See, this sort of people are not very happy, because anyway you ended up with a tester. Maybe it will be a low cost tester because only 20% of the total patterns will have to be stored, but it will still be an investment. Okay. So people have been looking for something that, if possible, eliminates this, right? So here is a solution that some people have proposed. It is called scan test compression. So what the idea here is like this: use automatic test equipment, use ATPG to generate a test, which have adequate coverage. Okay. So I had the circuit with scan, and I used ATPG, and I got, let us say, some 5,000 patterns, and I had about 96% coverage. Or 98%, whatever. Okay, and I am pretty happy with that. The only thing I am not happy with is that I will need an ATEs to store all these 5,000 patterns, etc. So the solution that the industry has come up with is, hey, let us use this good old PRPG and phase shifter, etc. Use the scan chains, the only difference is, can I somehow seed this PRPG so let us say for 5,000 patterns I have 5,000 seeds. If I can load the seed, okay, let us say seed 1, then I start the PRPG, start the PRPG and MISR. And it will actually uncompress the seed and generate the ATPG vector. Okay. So this is an amazing thing. Okay, we will figure out what seed, when placed in this PRPG and when the PRPG is operated, will magically produce the same test vector that the ATPG vector which was generated by the ATPG. What is the advantage? The seed is usually very small. So the entire vector will take a lot of space. There may be several hundred inputs here. So loading hundreds of bits from the memory, right, will require a lot of effort and lot of memory. So if we can replace that with just loading a small seed, maybe this is a 32-bit LFSR. So, the seed is only 32 bits. So, one 32-bit seed may be able to generate a complete ATPG vector. So, a single seed can generate or can be expanded or uncompressed into a test vector, into a scan test vector. Okay. If we can do this, then we have sort of made a great amount of progress, right. Sometimes we can be lucky, right. Having loaded one seed, maybe we can even generate more than one vector from the same seed. So, one seed may even be able to provide many test vectors. In the worst case, each seed corresponds to one vector. So, it sort of, you can think of it as a reverse engineering. Okay. If you are going in the forward direction, you will start with some seed and then apply clock cycles, and that will result in some scan vector, isn't it? See, seed 1 will lead to some scan vector. Now, the question is, can I go the reverse way? That is, you give me the scan vector and I will pre-compute what the seed might be, right, and that is a very clever solution. So, there are many companies that offer that solution. For example, when it was first announced, I think Mentor Graphics, which is now called Tessent. Okay. Originally, it was called Mentor Graphics. They came up with a solution called test compress. So, this was their solution. And then I believe Synopsys, which is another company, they generated another solution called as dBIST. Okay. So, dBIST means deterministic BIST. Okay. So, what we are saying is, it is no more a random solution, though it uses PRPG, etc. The seed will be uncompressed. So, if you have 5000 patterns which give you 96% coverage, you can take those 5000 patterns, use a tool like dBIST or test compress and calculate 5000 seeds. In the worst case 5000 seeds, but it may be fewer than 5000 seeds. And the seeds can be sort of there in the tester. Okay. So, the tester now does not have that much memory. Okay. It only stores the seeds. So, it can be expected to be a low cost tester, and we have it will use a miser to check whether the fault is caught or not. That means, if the golden signature is different from the actual signature, then the fault has been caught, a new different signature was generated. Okay. So, this is called test compress or test compression.